Alrighty, so let's take a look at this, and we're going to go over the review packet for the first. Okay, this is my first exam of this semester, and as soon as I touch the mouse, the thing's going to go away again, isn't it? There we go. Alright, so for this one right here, I'm going to open this up. So if I look at my standards on my notes, it says GCO A2. Alright, I'm going to open up my notebook. I'm going to find that one. GCO A2 is going to be on page 5. Same standard right here. So the A is a certain part of the standard, but it is still the GCO2. So it is there. It is there. So you could actually use this to find out which page in notes you need to go back over. So I have this. So page 5 in your notes is going to be very, very helpful here. So I'm going to go through and do some of this right now. So use the triangle below. For this problem right here, it says, for part A, it says, what coordinates of A prime, B prime, C prime after applying this transformation? So what type of transformation is this going to be? Yes?
Isn't this coordinate transformation?
Yes, it is. Also referred to as a translation. It is a translation. If you want to move over this way more, you're way back over there. There's some spots over here.
I can see.
Oh, you can? You got this? Okay. All right, so this is going to be a translation. So we did these first semester. So we have translation here. Now, let's take a look, and I'm going to do this. So for this right here, I'm going to take A, and for A prime, so I have this is my A. So x minus 1. So what is going to be my value here? So negative 6 minus 1 gives me negative 7, comma. What am I doing to the y value? Add 2. So I get negative 2. Very good. So there's A prime. Okay. B prime. So B prime is going to be, here's B up on top.
-3.
So it's going to be negative 3 and 6. There we go. All right, for C prime.
3 and -2.
So right here, I'm going to minus 1, so that's going to be 5. Right here. So 6 minus 1 is 5. And negative 4 plus 2?
-2.
Very good. Okay. That's it. Was that easy? Okay, all you have to do is go through and read this. Reading is probably the biggest issue that most people have in this class. Reading the instructions. So I was going over the problem B, part B, with someone, and they did not read it, so they did not know how to do it. But after I read it to them, they're like, oh, my bad. He even said it like that too. So right here it says using the original coordinates. What is the term that we use for original coordinates? Pre-image. Very good, right? The pre-image, right? So we have the pre-image. So that means I'm not using these. I'm using these up here. Now, according to this, what am I doing to each one of the values? I am multiplying it by 1/2, right? Multiplying by 1/2, or also I could say I'm dividing it by 2, right? So multiplying it by 1/2. So let's take a look at A again, which I have up here. So A, so negative 6 times 1/2 gives me negative 3, right? Negative 4 times 1/2. Negative 2. Now for B, B prime right here. So got to move this down a little bit. So right here, negative 2 times 1/2. Negative 1. 4 times 1/2. Positive 2. C prime. 6 times 1/2. Negative 4 times 1/2. Okay. So what did we do to both things there? We multiplied both by a half. If I'm multiplying both things by that 1/2, what am I actually doing there? I am reducing it, right? Very good. I'm reducing it. I'm shrinking it. Okay? The number 1/2 would be referred to as my, what we call that 1/2, we would refer to that as my scale factor. Very good. Scale factor. So the 1/2 is my scale factor, and I'm doing a dilation of this. So this type of thing is called a dilation. Okay, so it's actually on the bottom of my notes for the same thing. So I have my dilation here. There's my scale factor there, right? Okay. Now, for question 2. For question 2 right here, it says, given a polygon, so any polygon, on a coordinate plane, and the following motion rules state whether each is true or false. Okay, we're going to state which is either true or false. Now, they use a weird word for right here, preserves angle measure. Okay, now, here's the translation for that. This is what it means in regular words. So, is same size. I'm sorry, shape. Okay, is same shape. So preserves angle measure means, is it the same shape? Okay. What do we have here? If I have a negative x, negative y, what rule was that? It was first semester. What rule was that one?
Not like the reflection of a.
Yes, it is reflection what?
It was like it was like.
Over the diagonal, right?
Yeah.
Okay, or you could actually say it's reflection twice, right? Over the x and over the y. What was another thing that we would call? We would call a rotation also. Rotation would get us in the same spot. Okay, so if I think about that, if I'm rotating it or am I doing a reflection, is that the same shape?
Yeah.
Yes, it is. Is it the same shape? I'm going to say yes, it is true, because it is going to be the same shape. I know that a translation, a rotation, and a reflection all has the same shape and the same size. Okay? Right here. This preserves the angle measure. What did I do right here? What is this one right here called? What did I do? I reduced it by a scale factor of 1/2, right? Okay, so I reduced it. Now, when I reduce it, is it the same shape? Yes. If you're looking at your notes right here, here's my dilation, right? So if I'm reducing it, is it the same shape? It's the same shape, but different sizes, right? So it is going to be the same shape. So this, using a dilation, so this would be a dilation. Is it the same shape? Yes, so that's true. Now, this one right here. Does this preserve side length?
No.
No, it's not going to. Why? What does this do? What does this do? You were right. What did it do to my x value?
So it makes multiplied it by 3.
Yeah.
Multiply by 3. So is that getting bigger?
Yes.
So is that going to keep the same size? No, it doesn't. So the size is going to be different. Okay, so this is going to be a false. So this is going to be a false. Now let's take a look why. So if I'm looking at it and I'm only multiplying the x, right? I'm looking at my notes right here on page 5. What is it called if I'm only multiplying the x? Okay? If I'm only multiplying the x, what is it? It's a horizontal stretch, isn't it? So there it is right there. It's right there exactly in your notes. Horizontal stretch, that's it. If I'm only multiplying the y, it's a vertical stretch, isn't it? And if I multiply both of them by the same number, it's a dilation. Okay, good. So we have that. So let's take a look at the next one. The next one says GCO10. Okay, let's find GCO10 in my notes. So GCO10 is where? Page 11, isn't it? Right here. GCO10, page 11. Now, what did I point out is very crucial for this? These two things, for mid-segments. What is the very crucial thing?
Parallel.
Parallel and
1/2.
1/2. Okay, that's what I need. Flip the page. Let's look underneath. Hey, look, there's all my formulas in work. So midpoint, slope, and distance. Midpoint, slope, and distance. Let's take a look at our test. It's asking for the midpoint, it's asked for the slope, and it's asking for the distance. Exactly the same as what's on your notes. So we're going to go through and actually do this one like this. And I have a scratch paper here. Where are my other scratch papers? Still this one. There we go. All right. So we're going to go through, and in my handy-dandy notebook, I have my formula. Midpoint, slope, and distance. That's what I need. So let's take a look at my problem. So first thing it says, find the midpoint. So midpoint is my first notes. So we're going to find the midpoint of KL and LM. So KL and LM. Which one's my second point? L, right? Okay. So now for the midpoint. So the midpoint formula. Okay. So that means K is my first point. So what is X from my first point? 2 plus. What is X from my second point? -2 all over 2, comma. What is Y from my first point? Plus Y from my second all over 2. Did I lose anyone? Okay, so let's go through and do our math. -2 or 2 plus -2 gives me 0, right? 0 over 2. And 4 plus -2 is 2. Divided by 2 is 1. So I have 2 over 2, which gives me, so I have 0, comma, 1. And according to my thing, it says label them R and T. So this is going to be my R point. Now let's do the same thing for LM. What is X from my first point? -2. Is there one just not awake yet? Or falling asleep slowly?
I'm awake.
Plus, what is X from my second point? 4 all over 2, comma. What is Y from my first point? Plus, Y from my second? What is it? There we go, all over 2. So this right here is going to give me a +2, right? So it's 2 over 2 and negative 2 plus negative 2, negative 4, right? Negative 4 over 2, which gives me the point 1 comma negative 2, and according to what they said, label that one t. So let's go ahead and put those on my graph. So r is at 0, 1, and t is at 1, negative 2. And I'm going to connect my dots. There we go. Now, I have that done. Okay, so part A is done. Now let's take a look at part B. Calculate the slopes of RT and KM. Slopes of RT and KM. So I have my formula right here. What's Y? So I have my points right here. And you know what? To make this a little bit easier, K is 2, 4. L is negative 2, negative 2. And M is 4, negative 2. So make that a little bit easier so we could have all the points on one page. All right, so slopes. So for my slope formula, so T is my second point, right? So what is the Y from my second point? So negative 2 minus, what is Y from my first point? 1 over. What is X from my second point? It's 1, right? Minus X from my first point. 0, right? Okay. So what do we get on top? So what do we get on top here? I get negative 3 over 1. Okay, there's my slope. That's the slope of RT. Now, let's take a look at KM. We're going to do the same thing for KM. Which one's my second point? It's M, right? So now, if M's my second point, what is Y from my second point? Negative 2 minus, what is Y from my first point? 4 over, what is X from my second point? Minus, what is X from my first point? Do my math, I get negative 6 over 2. Can I reduce that fraction?
Yes.
What does it reduce to?
Negative 3, 1.
Negative 3 over 1. Are those the same?
Yes.
Now, if you paid attention to the notes, what happens if I have the same slope? Parallel. Because we know parallel lines have same slope. Same slope. Same slope. Parallel lines have? Very good. You guys are going to, like, every time that word, it's going to come up almost every day for the rest of the semester almost. Okay? So, parallel lines have? So, are these the same? Yes. So, what does that mean? They're parallel. Let's take a look at my notes. What does part 1 of my thing say? Mid-segments parallel. Are they parallel? Yes, they are. Hey, look. I'm done with part 1 right there, right? Okay. So, I calculated it here. So, it's going to be, so just for the sake of, I'm going to actually put it on here. So, it's going to be RT is negative 3 over 1, and KM is negative 3 over 1. Okay, I put the midpoints up here, so it is showing work for this. All right, so let's take a look for the last part. It says calculate the length. Okay, that's the exact same thing I did in the notes for the second part. So, That's using the distance, right? Okay, we have distance. My distance formula is right here. The little triangle is called a delta. What does delta mean? Change. The distance, the difference, right? How far are they apart? Okay, so I need to do the same thing for RT and KM. RT. Now, let's take a look. Scroll down a little bit here. Okay, so now for RT, delta X. How far are my X values apart? 1, so it's 1 squared plus. Now for the Y values, how far are my Y values apart? Very good, it is 3. Okay, so it's 1 this way, right? And to -2, that's 3 apart, right, Master? So it's going to be 3 squared. I do my math. 1 squared is 1. 3 squared is? Add them together, I get? Okay, that doesn't come out nice, but we're going to put that in the calculator here in a minute. All right, so now let's do Km. So Km are the ones up here. So for my X values, how far is 2 away from 4? 2, okay. So it's 2 squared plus. Now for my Y values, my delta Y, how far is my Y's apart? 6, right? Okay, so I'm going to have 6 squared is going to be 2 squared is 4. 6 squared is? Okay, so 4 plus 36 gives me 40. So I'm going to have the square root of 40 here on this. So let's go ahead and write that. So is that 1/2? I don't know yet. So there's a way of actually figuring it out. So if it has this, okay, so if I'm doing this, I could actually write this out as a fraction, or I could do it as decimals also. So doing it as a decimal, so as a decimal, I'm going to take a look. You guys see that? Okay. So control divide 10. Okay. Control divide 40. It looks like it could. It's 3.16 and 6.32. It looks like it could be. I can't really tell because the decimals don't match up exactly like it would be 1/2. It could be. Okay. Now let's try this. So if it's 1/2, it should be square root of 10 over square root of 40. That should give me 1/2 if I'm doing it correct. So let's try that one now. In your calculator, everyone, please, because you're going to have problems like this and you need to be able to identify this and put it in the calculator correctly. So please do this. Write me out. Master, write me out. Yes, calculator. New Win, did you already do it? Okay.
Wait,
So control divide, radical 10 over radical radical 40, like that. Let's see what we get. 0.5. Is that 1/2? Yes, it is. It is 1/2 as a decimal. So that is 1/2. So did it meet my requirements of my two things?
Yes.
Lines are parallel and it is 1/2. So if it's parallel and 1/2, what does it mean that it is? It is the mid-segment. Okay. So let's take a look at my thing. So RT is square root of 10 and KM is square root of 40. Okay, so now from there, using your calculations from A, B, and C, explain relationship RT to the triangle. So RT is the mid-segment. of the triangle. Does that make sense? Now, is this helpful going over this like this? Every single one of these problems are straight out of your notes. Straight from the notes. I don't give you a whole bunch of homework in this class because every single problem I give you is practice for the test. So if you're doing practice for the test, then it is practice for, the class. So you should have a good grade out of this. So I'm going to leave off right here, and I'm going to let you guys use the rest of the class to actually finish up your notebooks. You guys got to make sure your covers are on. You got to make sure all your practices are done. And the one thing that really helps you get ready for the test is summaries. Now, I'm going to go over summaries here in a second, but I'm just going to stop the video. So don't forget, like and subscribe and comment. And Master's going to do a trick if we get 100 views.